This is Cramer, ACT Prep, Acids and Bases. Alright, we are reviewing for ACT, MME. We are looking at one of the areas in which students are scoring low on the chemistry portion. One of those areas is acids and bases. So a quick review. Acids. Acids are compounds that have a hydrogen ion. Remember that an ion is just a charged element, so hydrogen has a positive charge, and when you add that compound to water, the hydrogen breaks up into these charged particles. So hydrochloric acid, which is a very strong acid, when we put that into water, dissociates, which means to break down into the ions, the hydrogen ion and the chlorine ion. Some typical acids are many of the foods we eat, citric fruits like lemons and oranges, apples, tomato sauce. Acids typically have a very sour taste and feel squeaky if you were to rub them between your fingers. Bases, on the other hand, are compounds that add a hydroxide ion to water, and hydroxide is oxygen and hydrogen bonded together. So if we have sodium hydroxide, which is a very strong base, and put that base into water, it will dissociate or break down into the hydroxide ion and the sodium ion. Many of our cleaning products are basic. Ammonia, which is basically Windex, soap, bleach, and if you think that they neutralize acidic food, that's why we use them to clean. Bases have a very bitter taste, even though we don't normally eat them, and feel slippery between your fingers. Strong acids and bases will ionize almost completely in water, meaning that all of the compound will dissociate into ions. Weak acids and bases ionize incompletely. Just a few ions from the compound break apart. Both strong acids and bases can both burn your skin and eyes, so we have to be careful when using both. We measure acids and bases using a pH scale, and you should be familiar with the pH scale all the way from elementary school. We have a scale from 0 to 14. 7 is neutral in the center, and we use distilled water as our example of being a 7 or neutral. The stronger the acid, the lower the number. So if we start going down, we have vinegar, then lemon juice, all the way to concentrated hydrochloric acid or battery acid. On the other side, bases, again, going up in the scale, the stronger the base. So starting with baking soda, then bar soap, ammonia, all the way to concentrated sodium hydroxide. Two important concepts with acids and bases, and that's neutralization. Neutralization, also called titration. When acids and bases are mixed together, they neutralize. So if you had an equal concentration of an acid and a base, it's neutral. And here we have a hydrogen ion, a hydroxide ion, and when we put those together, they neutralize to form water. A typical neutralization reaction would be hydrochloric acid plus sodium hydroxide, and that's going to give us a salt, NaCl, table salt, and water. It's important to note that chemists will call any ionic compound, any metal and non-metal, they're going to call that a salt. Sodium chloride is a special salt, table salt, one we're used to, but don't forget that chemists call any ionic compound a salt. And it's also important to know that one of the products of a titration will always be water. Our second concept that's important with acids and bases is how to dilute acids. We never ever add water to a concentrated acid. When you add an acid to water, it produces a ton of heat. Acids are more dense than water, so if I add water to a concentrated acid, the water then sits on top. It floats. It causes it to flash boil or boil really quickly, and can cause it to splash up out of the acid along with the acid. Hot water could cause incredible burns. So we always, always, always add acid to water. Alright, if you would flip over your paper for me, one more concept that we're going to talk about before moving on. is pH and acid rain. Plants and animals need water that's close to a pH of 7 or neutral to survive. But because of pollution in the air due to combustion from cars and other machinery, the acid in the rain causes it to be less than a 5.6. Any rain that has a pH of less than a 5.6 we call acid rain. And acid rain can kill plants, can cause asthma, other physical problems in humans. It also eats away at many statues and historical landmarks. The Roman ruins, the pyramids of Egypt, other treasures around the world are slowly dissolving away by acid rain. They've said that more damage has been done in the last century than in the last 2,000 years. So it's important to find ways to stop this pollution, acid rain, so that we can keep these treasures forever. Alright, as a review on your paper, we are going to go over some of the vocabulary that we just talked about and answer some questions.